Hello, my dear students. How are you? Are you fine? I hope you are fine and watching my video. I am back here with the remaining part of hydrocarbons. So today we will discuss about the alkyl radicals, functional group, homologous series, and alcohols. So let's start with the very first topic, that is alkyl radicals. Here, alkyl radicals are represented by capital R. What are these alkyl radicals? When a hydrogen atom is removed from an alkane, then alkyl radicals are formed. Their general molecular formula is CnH2n plus 1. As you know that the molecular formula of alkane is CnH2n, and if one hydrogen is removed from the alkane, then what is formed? Alkyl radical is formed. So we have to remove one hydrogen from the general molecular formula of alkane to get alkyl radical. It means, suppose there is alkane. Alkane are generally like this, R H. These are alkane. When one hydrogen atom is removed from this alkane, then what is formed? R is formed, that is alkyl radical is formed. Now this alkyl radical, its name, it's similar to the name of alkane, just in alkane there is ANE, but in alkyl radical there is YL at the last. Like if we talk about CH4, it is methane. From methane, if one hydrogen is removed, then what is formed here? CH3 is formed. This CH3 is called methyl. There is C2H6, that is ethane. From ethane, if one hydrogen is removed, what is formed there? C2H5, that is ethyl. Simply remove this A and E and add YL in the name of that alkane to get the name of alkyl radical. So this is methyl radical, this is ethyl radical. If we talk about the next member of alkyl radical, then what is the next member of alkane? C3H8, it is propane. From propane, if one hydrogen is removed, then we get C3H7. This C3H7, what is the name of C3H7? Propyl radical. In the same way, we can get another radical which is called butyl radical, pentyl radical, hexyl radical, and so on. So after alkyl radicals, let's talk about the functional groups. So what are functional groups? The atom or group of atom that present in the organic compounds that determine the physical and chemical properties of the organic compounds are known as functional groups. There are certain atoms and group of atoms present in the organic compound other than hydrogen and carbon. That atom or group of atom which are present in the organic compound determine the complete physical and chemical property of that organic compound. Such atom or group of atom are known as functional group. Like there are some caste system. There are many people having same name. Like there is a person Ram. This Ram is Sa. Another Ram there is Gupta. Another Ram there is whose name is Ram Roniar, or many other castes are there. Like the caste of human being, there is functional group in the organic compound. These castes determine the culture of that person. In the same way, the functional group determine the physical and chemical property of the organic compound. Now there are some functional groups in the organic chemistry. Let's see some examples of the functional group. Functional group, their name and suffix used for them. There is functional group OH, name is alcohol, and the suffix used for the alcohol is ol. There is functional group COOH, which is called carboxylic acid, and the suffix used for carboxylic acid is oic acid. Similarly, there is COH, which is called aldehyde functional group, and the suffix used for aldehyde is -ol. In the same way, there are many other functional groups in the organic compound. Every functional group have their unique formula and structure, and they also have a particular suffix. If there is OH group in any organic compound, that means the organic compound is alcohol. If there is COOH group in any organic compound, that means that organic compound is a carboxylic acid. If there is COH in any organic compound, then that means the organic compound is an aldehyde and its suffix is -ol. So these functional groups determine the physical and chemical property of organic compound. Now after functional group, let's talk about the homologous series. Homologous series. Now this homologous series means what? The series of organic compounds having the series of organic compounds having same functional group where the successive members differ by CH2 group is known as homologous series. Homologous series. If there is a group or series of organic compound having same functional group, then such a group or series of organic compound having same functional group is known as a homologous series. Let us take an example of homologous series here. The homologous series of carboxylic acid we will take here. Example of homologous series of carboxylic acid. Homologous series of carboxylic acid. Carboxylic acid. Suppose there is a series like this HCOOH. This is the first member of carboxylic acid. As it contains only one carbon, its name is methanoic acid. Methanoic acid. What will be the next member? As it is mentioned here, the next member will differ by CH2 group. Just add CH2 here. So what will be there if we will add CH2? We can write CH2H, that means CH3. That this H also added here, CH3 COOH. Now there are two carbon. If there is two carbon, the name will be eth, and the name will be ethanoic acid. Since the oic acid means what? Carboxylic acid. Oic acid is the suffix used here. The next member, what will be the next member? CH3CH2COOH. Its name will be propanoic acid. Similarly, here this CH3CH2COOH, we can write this another way also, like C2H5COOH also we can write for this propanoic acid. Then the next one is CH3 CH2. Now add one more CH2 here, CH2 COOH. And what will be the name? Since there are four carbon, its name will be butanoic acid. Next one will be pentanoic acid. And what will be the formula? Just see here. In this formula, there are how many carbon here? Before this COOH, 1, 2, 3. C3H7 COOH. We can also write this for this propanoic acid. Then, now you tell me what is the formula of pentanoic acid? C4H9COOH. Hexanoic acid, C5H11COOH, and so on. In this way, we can remember the homologous series. In every homologous series, the successive member differ by CH2 group. But everywhere there is same functional group. Okay, so this is about the homologous series. After homologous series, let's talk about the alcohols now. What are alcohols? Alcohols, the organic compounds having hydroxyl in bracket OH functional group functional group are known as alcohols. For example, if there is a compound here 1, 2, 3, and here is OH. Whatever other atoms are there, that doesn't matter. Suppose there are other hydrogens here in this compound, but there is OH functional group. Then this is a alcohol. If there is another compound CH3OH, there is OH functional group. This is also alcohol. Whenever there is OH functional group in any organic compound, then such organic compound belongs to alcohols. Now these alcohols are basically classified into three types on the basis of number of hydroxyl group present in them. So those three types of alcohol, what are they? Let's see. Number one, monohydric alcohol. Number two, dihydric alcohol. Dihydric alcohol. Number three, trihydric alcohol. Now, what are these monohydric, dihydric, and trihydric alcohol? Let's discuss about them one by one. All these are alcohols because they contain OH group. Now, on the basis of number of OH group, they are classified into mono, di, and trihydric alcohol. Number one, monohydric alcohol. Monohydric alcohols. The alcohols having only one OH group are known as monohydric alcohols. Monohydric alcohols. They are generally formed generally formed by replacing one hydrogen of alkanes with one OH group. Their general molecular formula is CnH2n plus 1 OH. Now let's take an example. Suppose there is methane. This is the structure of methane. From methane, one hydrogen is removed and one OH is added in the place of that hydrogen. Then what will be formed here? This OH is added here, suppose. We can add that OH anywhere. Then this is what? An alcohol. And since it is alcohol having only one carbon, here if there is one carbon, the name start with meth. There is single bond, so methane, but E is removed here by the secondary suffix ol. So its name is methanol or methyl alcohol. Methyl alcohol. The next one is another alkane having two carbon atoms. Here the name of this alkane is ethane. If one hydrogen of ethane is removed and one OH is added, then we obtain another alcohol, that is ethanol or ethyl alcohol. This ethanol or ethyl alcohol is a very common type of alcohol, basically used and found in the alcoholic beverages for drinking purpose. This is the alcohol which is used in most of the drinking alcoholic beverages like vodka, whiskey, beer, or all kind of alcoholic beverages. Which alcohol is found there? Ethyl alcohol or ethanol. This alcohol is also used in the thermometer as a thermometric liquid. Now, after the monohydric alcohol, the next one is dihydric alcohol. What are dihydric alcohols? Dihydric alcohols, here di means two, mono means one, di means two. So, dihydric alcohol means dihydric alcohol, the alcohols having two OH group are known as dihydric alcohols. Generally they are formed when two hydrogen atoms are hydrogen atoms of alkane are replaced by two OH group. Here the general molecular formula of dihydric alcohol is CnH2n OH whole 2. There are two OH group. Now we can see here, if there is an alkane, suppose this alkane have two carbon atoms, its name is ethane, and if two hydrogen of this ethane is replaced by two OH group, then what is formed here? We obtain here a dihydric alcohol. Its name is glycol, or its IUPAC name is ethane 1,2 diol. So after dihydric alcohol, let us talk about the trihydric alcohol, the next type of alcohol. Here di means having two OH, tri means having free OH or 3 hydroxyl group. If any alcohol have 3 hydroxyl group or 3 OH group, then such alcohol is known as trihydric alcohol. Trihydric alcohol. The alcohol having 3 OH group are known as trihydric alcohols. These alcohols are formed by replacing 3 hydrogen atoms of alkane with 3 OH group. Their general molecular formula is CnH2n minus 1 OH whole 3. Now, after this, let's see how it is formed. Let us take an example of alkane having 3 carbon atom. Here the name of this alkane is propane. This is propane. From propane, if we remove 3 hydrogen atom and we add 3 OH group, then we get a trihydric alcohol. OH, 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 H. Now the name of this trihydric alcohol is propan 1, 2, 3 triol. Commonly it is known as glycerol. So why we write this number in the IUPAC nomenclature? That for that you have to know about the rules of IUPAC. But here in the class 10 level students, just you have to understand that here are 3 carbons, 1, 2, 3, 1 number, 2 number, 3 number, and each carbon there is OH group. So we have mentioned here 1, 2, 3, and since there are 3 OH, we write tri for 3, and OH means ol suffix. So propane 1, 2, 3 triol. Now this glycerin or glycerol, which we generally use in the winter season to protect our skin from crack due to the cold, that same glycerin is that. So that glycerin is a trihydric alcohol. Now if you want similar type of video from me, then please subscribe the channel and share with your friends so that I will bring some more videos related to class 10 chemistry. Thank you.